Hello, welcome back to part 3 of the mean value theorem. In this video, I'm just going to go over example number 7, dealing with a composition of function from a table of values to apply the mean value theorem, and then also kind of go back to the intermediate value theorem and kind of talk about when do we use which existence theorem. All right, example number 7, they say let g be a twice differentiable function. Selected values for g and its derivative g prime are given in the table above. Let h be defined by the function h of x equals g of x minus 3x. All right, so A, they say show that there is a time c from -2 less than c less than 6 such that h of c is equal to -4. Okay, well, when they give us the function and they ask us to show that a value exists on this function, this is almost always going to be the intermediate value theorem. Now, I do need to go ahead and state my conditions, and the first one is that in this case, h is continuous. How do I know h is continuous? Well, what they say is that g is differentiable. And so we can say since g is differentiable, it is continuous. And therefore, h is continuous. H is continuous. Okay? And that's how it works. If I have a function that is defined or made up of composed of continuous functions, then that function is continuous as well. So there's our first condition. Really, that's the only new wrinkle. The rest of this is going to go just like the rest of our examples. So here I now need to show, if I'm using intermediate value theorem, that -4, the value that they want, is between h of -2. And so I'm going to have to do some lifting here. I'm going to have to go ahead and plug this in to this composite function. So g of -2 minus 3 times -2. So g of -2 looks like is 4. So I have g of 4 plus 6. And g of 4 is 5 plus 6. This is going to give us 11. Okay, now I'm going to do the same thing, but this time for 6. So I'm just going to plug in 6 into my function here. So I have g of 6, and g of 6 is 3. So now I have g of 3 minus 18. And g of 3 is -3 minus 18. That equals -21. So I'm just going to go ahead and show this. Is -4 between these values? Yes. -21 is less than -4, which is less than 11 in business. So now I just need the conclusion. Okay, now I've already showed my statement. I've already written out since g is differentiable, it's continuous, and therefore h, by consequence, is continuous. So I can say since h is continuous and -4 is between h of -2 and h of 6. Now we apply our conclusion. There is a time, what do they say, c for -2 less than c to less than 6, such that h of c equals -4. That's the intermediate value theorem. There you go. I don't state the intermediate value theorem because if you misstate what it is, you're going to lose the point. But that's what we're applying. We're applying the IVT there. B, they say show that there is a time k for -2 less than k less than 6 such that h prime of k is equal to -4. Ooh, the prime. Okay. Well, now they're asking us about the derivative. Well, this is going to be the mean value theorem. The first condition, is it differentiable? And is it continuous? So I got to go ahead and I have to state this again. Number one, so they told us since G is differentiable, and therefore continuous, comma, we're going to say H is differentiable and continuous. And I know you may be saying, Schwarberg, that's like, duh, like obvious. It's like, why do I have to restate that? Well, you need to restate that. You need to, one, acknowledge that differentiability implies continuity, as well as you understand that if G is differentiable and continuous, therefore its composition H is. So you have to state that, as well as what you're doing is you're checking off the checklist in order to apply the MVT. Now, what I do need to show here is I need to show now that the average rate of change, that h of 6 minus h of negative 2 over 6 minus negative 2, I need to show that this is equal to the value that they want. Now, I'm keeping my fingers crossed. I'm using these exact values. I'm not going to go hunt for values unless this is wrong, because I already computed these values. I already know what h of 6 is. That's negative 21. And I already know what h of negative 2 is. That's 11. So I have negative 21 minus 11 over 8. This gives us negative 32 over 8, which is, in fact, negative 4. There we go. So now I need to go ahead and just state the conclusion. And our conclusion is, since h is differentiable and continuous, there is a time k for negative 2 less than k less than 6, comma, such that, and here's where I just state what the mean value theorem says. The IROC is equal to AROC. So h prime of k is equal to, and I'm going to say here, h of 6 minus h of negative 2 over 6 minus negative 2, which is equal to negative 21 minus 11 over 8, which is equal to negative 4. I don't completely rewrite this whole section here, but I want to show the average rate of change setup, and then I want to show that difference quotient, right? The difference in the numerator and the difference in the denominator. I want to show that at least some of those function values, and that it equals that value that we wanted, okay? And there is our conclusion. That is it by the mean value theorem. Again, I don't state mean value theorem, but I showed the conditions. I can go ahead and apply it, and we are good. If you use IVT by mistake, then you lose the point. We don't want that. All right. Hope you learned a little bit more rigorous, involved example on the mean value theorem and the intermediate value theorem in this video. I'll catch you in the next one. See ya.